Hi, I'm Chris Steves. Welcome to Norton Engineering University. Today we'll be discussing process troubleshooting for refinery engineers, and we'll be reviewing an overview and principles associated with effective process troubleshooting. Future videos in this series will include case studies that apply these principles to solve problems in refineries and chemical plants. Troubleshooting is an essential skill for process engineers to have, and it's important that you develop this skill over the years so that you can become more effective as a process engineer. It comes from experience, so it's important that you start early. It must be used as a skill to learn and grow as an engineer. It's not just something you can read about. You've got to try and put it into practice and learn as you go. And it's also a team sport. Troubleshooting is best done with others, so make sure that you try and get help when you need to and consult with others that may have done this more than you. Just as a house needs a strong foundation in order to stand strong, so you as a process engineer need a good foundation in order to become an effective troubleshooter. Important, first of all, is to make sure that you've got a basic understanding of engineering principles and rules of thumb that you can use when you're out in the field. You also need to know how your unit works, how it fits into the refinery or chemical plant in which you're working, and the key properties and parameters of all the process streams and unit operations inside that unit. You need to make sure you talk often to the operators that are running the unit, as well as other engineers, subject matter experts, and other support disciplines. It's also important that you actually have physical tools that you need so that you can effectively troubleshoot. Things like pressure gauges, temperature guns are all important to have. And you also want to make sure that you're prepared to use all of your senses when you're troubleshooting unit problems. One note on safety. Safety is critical in all that you do inside your chemical plant, and especially when troubleshooting, when things may be going wrong. So when you're performing field work, make sure you keep safety in the front of your mind. Understand and comply with all of your plant safety standards and requirements. Never, ever take shortcuts with PPE or in following safe work practices. Always, if possible, work with others, preferably a unit operator, when performing field work. And always listen to the safety concerns of others and stop all work if an unsafe situation develops. First thing you want to do when you're trying to troubleshoot a problem in a chemical plant is you need to understand what the problem is. It's important at this stage of the investigation that you do not jump to conclusions about the cause of the problem. You need to collect the evidence and then let the evidence point to the diagnosis. It's also important at this stage that you don't rush to use more advanced technology or more advanced troubleshooting techniques, things like tower gamma scans or tracer tests. It's important you try and collect more basic information first. If you rush to perform tower gamma scan before the basic data is collected, that can be a waste of time and money. It can actually point you in the wrong direction. So get the basic information first and then move along to more advanced troubleshooting technology. It's important when you're trying to understand what the problem is that you identify what the symptoms of the problem are. Don't skip right over the symptoms to the diagnosis. Just as in medicine, a fever, which is the symptom, can be caused by a lot of different things, including an infection, a virus, or some other trauma. The doctor needs to understand all of the symptoms to make an accurate diagnosis. And the same is true for you as a troubleshooter. You need to understand the symptoms before you can make the diagnosis. Tower flooding, for example, is a diagnosis, not a symptom. There may be symptoms of tower flooding that can be things like high pressure drop, liquid carryover, and poor fractionation, but these can also be symptoms of other problems, so it's important to understand what all of the symptoms are associated with the issue before you jump to the diagnosis. Collecting data around the problem includes a lot of background data. Make sure you collect all the PFDs and P&IDs for the impacted system. You want to try and collect equipment drawings and design data sheets to understand how the equipment is supposed to look and how it's supposed to operate. You want to try and collect prior test run data and mass balance information so that you have a good understanding of how the unit was operating before the problem happened. And also you want to look for historical information going back years and years if you can on unit performance or on any modifications that have been done. It's very possible that you may not be trying to solve a new problem. It may be an old problem that someone else has looked at, and having that history can help you a lot in trying to understand what may be going on. Next, you want to try and collect data around the current problem symptoms. You want to collect all of the current system data that you can, things like flow rates, temperature profiles, and pressure drop. But it's important you not only collect this information from your data historian or from the control room, but get out in the field. Try and verify some of this instrumentation data that you're getting in the control room with actual data from the field as well. It may be possible that your instruments are lying to you, they need calibrating, or they've got some other operating problem. And it's important that you try and understand if your instrumentation is working correctly or not as a way to try and diagnose the problem. It's important that you also try and collect stream quality information. Understand where your stream gravity, distillation, sulfur, and other contaminants may be, and how that compares against normal operation. And also, if possible, you want to try and observe the symptoms for yourself. They may originally be reported to you by something that happened overnight from the operations team, but it's important that you try, if possible, to try and verify these things for yourself, see them with your own eyes. And it's also important to try and see them not only from the control room or from your data historian, but also in the field. You may pick up things in the field that are happening at the same time that are originally being missed that may give you important clues as to what the root cause is. It's also very important that you talk to the people who are involved. Talk to the console and board operators, the field operators, supervisors, other engineers, subject matter experts. You need to listen to what they have to say. They may be jumping to conclusions and jumping to inaccurate diagnoses of what the problem is, but it's important you understand why they're making those leaps and trying to come up with the diagnosis of what the problem is. Their description of the symptoms may be very, very helpful to you so that you could try and understand what may be really going on. Some questions for the people involved. When are the symptoms seen? Are they continuous or are they happening intermittently? And can you reproduce these symptoms by adjusting the operation of the unit? Once you've collected all the system data, then it's important that you organize and analyze the data so that you can try and understand what's happening. The old saying is a picture is worth 1,000 words, and that is absolutely true when it comes to trying to analyze data that you collect during troubleshooting. Draw pictures of the system. It'll help you in understanding how the system looks and how it's working. And also use graphs to assist in the analysis of the data as well. You may see things from a well-drawn trend that you can't see necessarily by looking at the raw data. Develop some potential hypotheses for potential causes based on the data that you've collected. And then once you've developed a hypothesis, figure out a way that you can test that hypothesis or collect additional information that'll help in either supporting or discounting that hypothesis. At this point in your troubleshooting, it's probably more effective to use advanced technology such as tower gamma scans and tracer tests than initially. If you test your hypothesis and it's rejected, it doesn't make any sense, then you need to discard that and try and come up with a new one. And keep on testing these hypotheses via a process of elimination until you end up confirming one of the hypotheses. Try not to get attached to any one hypothesis, either your own, your boss's, or an outside expert's. If you become too emotionally attached to any one hypothesis, it can result in wrong conclusions, and it can become a waste of time and money while trying to find the real problem. Once you've figured out what's going on, you need to communicate what your conclusions are. It's important that you explain what process that was used in order to try and reach your conclusions. Use drawings, photos, again, and graphs to try and communicate that information. They're going to be very effective in trying to tell a story so that the people that you're communicating with understand what you found. Explain the hypotheses that were generated and what testing you did in order to try and rule them out or rule them in as the root cause. And present your conclusions and recommendations so that you can move forward. Thank you for attending this Norton Engineering University presentation on process troubleshooting. Give us a call. We'd love to help you if you need assistance in process troubleshooting, project development, or other process engineering needs.